the next couple of steps. Again, the first one is the takeoff weight buildup, mission analysis, and the constraints. So in this video, we'll talk about the takeoff weight buildup, and in the next video, we'll talk about the constraints. All right. Again, the goal here to estimate the gross takeoff weight of the aircraft depending on the mission. The mission profile of your aircraft should actually come from the requirements, right? And we also need to estimate depending on the mission that you have. We have to estimate the fuel weight of the aircraft. So we'll do a mission analysis. Next, we'll see that whether or not you can satisfy all the requirements that are posted, through what is called a constraint analysis or constraint diagram. Because in the end of the day, you only have one aircraft and you have several constraints. So you have to make sure that that one aircraft that you're designing is able to meet most or in fact all of the constraints that are listed, right? And that's basically what our design point of the aircraft is. The design point is selected based on the requirements, based on satisfying like all the requirements that are posted. All right, so let's jump straight into it. Again, it's very important as you move through this design process to have good set of resources, because all of you are designing different aircraft, right? So whatever we're going to talk about in this videos in class, it can be generic, but a specific information that you need to design your aircraft can be found in one of those, or a couple more of those textbooks. So depending on what type of aircraft that you're designing, you can choose a textbook to actually go with and refer to. Right. Again, you can say Raymond Roscom, fighter bomber transport. Roscom is fighter general aviation. Tornbeek is good for commercial and transport. Nikolai is fighter general aviation and transport. Kundu is general aviation transport. Goodmanson's purely general aviation. Jenkinson, civil jet transport. Stinton, anything alternative. Like if you're designing some alternative designs like Burt Rutan designs, any like unusual designs for an aircraft, Stinton is a good book to refer to. Corky, again, any sailplanes and high aspect ratio wings is good. It's a good reference for that. Haneke is for fighters, and Whitford is for fighters, and Howe is for transport. So the neat thing is I collected PDF of all of these books from online resources, and I put it in the Google Drive for you to use. So if you just go to this link, you can download all of these books and refer to as you're going through the design process. So again, you don't go with one textbook. Download a couple of more, two or more, so that you can have like multiple point of view, multiple resources to go with. It's very important that you will find some very, very valuable information, in those books, all the way from estimating empty weight, CD zeros, aspect ratios, and so on. Right? It'll really help you do the build-up, historical build-up, but also it'll help you make educated assumptions as you go through the design process. Okay, and I cannot emphasize the importance of having these textbooks. All right, having these textbooks next to you so that you can refer to it. Right, so it's definitely an invaluable resource. All right, so make sure to download them. All right, so let's jump straight into the takeoff weight buildup. Again, our goal here is to be able to take off gross, we estimate the takeoff gross weight. So the takeoff gross weight is essentially the design weight of the aircraft and not really the max takeoff weight, because the max takeoff weight is really dependent on what's the maximum weight an airplane can carry, right? So for example, like F-15s have a design weight, but they if they want a longer range, they can attach fuel tanks, but that they don't fly with fuel tanks more often, right? It's only in specific times and scenarios. But that's basically limited by the amount of extra fuel they can carry to their max takeoff weight. We'll estimate that, but for now, we want to size our wings based on the design weight and see how much we can push it further, right? So the design weight, and then we'll estimate the fuel weight of the aircraft as well through the mission analysis. So here is the the breakdown of all the weights for the aircraft, right? The W naught is the gross takeoff weight. And then you have the crew weight and the payload weight, which should basically come from the design requirements. Right. So when you're going through the historical buildup and the requirements, this is something that you need to know, after you or during the process of setting the requirements and then the historical buildup, right? So this is something that we know, right? You start this step, the takeoff weight buildup, with this information in hand, and then the idea is to estimate what would be the empty weight of the aircraft on the field weight of the aircraft, right? So once again, right, this empty weight and field weight, okay, we're gonna make some estimations based on generic formulas and methods, but please make sure to refer to your own, your like textbooks that's based for that's written for the type of aircraft you're designing, to get a really good, reasonable and estimates, right? So ultimately, like these fuel weight and empty weight really depend on the weight of the aircraft, the gross weight of the aircraft as well, because depending on how much weight you carry, may need more fuel, and depending on what type of missions you want to do, you want more fuel, but that ultimately increase the total weight of the aircraft too, right? So and you need the structures to support that as well. So depending on what type of systems you have, the empty weight of the aircraft will increase as well, right? So if you have a variable sweep mechanism, then that's going to add to your empty weight, right? If you add more empty weight, well, that's going to increase your weight, so you need more fuel, right? So that means it becomes an iterative process. If you change one, you're ultimately changing the other, right? So that's exactly what we're going to do. We're going to look at an iterative process to estimate the takeoff weight of the aircraft by doing some analysis on the empty and the fuel weight, right? So, but just because the you fuel weight and empty weight depends on the W naught or the gross takeoff weight, it's good to work with ratios. We work with fuel weight fraction and empty weight fractions. Once again, this is one of the reasons why I ask you to find these empty fractions during the historical buildup, because you can have an idea of what those fractions look like for the aircraft type you're designing. All right, so we'll solve for W naught. We'll end up getting this equation. So basically, it is this equation that we are solving for. We estimate and we start with an estimate for a takeoff weight, right? And in the left-hand side, and then when we plug in our empty weight and fuel weight, whatever the right-hand side ends up, say if it's different than the left-hand side, then we'll do the iteration again until we converge to a solution that we want, right? So basically, the left-hand side should be equal to the right-hand side, right? That's our goal here. And that will give us a good estimate of takeoff weight to start with, so that you know how big your wing should be, right? Provided that it actually meets the constraints, actually meets the requirements, that we'll see in the constraints. All right. So a little bit about the empty weight estimation. So empty weight is a combination of all the weights that's except like fuel and payload, right? So you got the structure weight, you got the engine weight, you got the landing gear, you got the avionics, and any fixed equipment. So this is one of the reasons why I wanted you guys to do a system level breakdown of of what systems you need for the aircraft to satisfy the mission, so that you can account for those as well, right? Again, the first method that can use to estimate empty weight is just from historical data, right? You can identify trend lines between the empty weight and the takeoff weight of the aircraft. So ultimately, what we're trying to get is some sort of function that you can use to estimate your empty weight as a function of takeoff weight of the aircraft, right? I mean, you will get some trends in here, correct? You get linear, quadratic, it's essentially, you'll see some trends in there, but ultimately that's what we want is an empty weight as a function of a takeoff weight. And this is something that you can definitely rely on, because you collected the data based on the aircraft type that you want. The methods that we're going to talk about, the next methods that we're going to talk about are from a generic standpoint, but this is basically specific to what it is that you want to design. So given a choice, I would choose this method first before any other methods, right? So now, if you could not see any trends depending on the aircraft that you picked, right, then you can definitely rely on other methods as well. Those methods are actually discussed in Raymer, Askham, or Nikolai, or any other textbooks. So I'll discuss a couple of methods from Raymer and Nikolai. So in Raymer, if you look at chapter 3 of Raymer, he basically talk about the takeoff weight estimation. Right. So here you have the empty weight fraction on the y-axis and the takeoff weight on the x-axis. So you can see the slopes for different aircraft types in here. And then there's a table which you can use to quantify the empty weight for a given takeoff weight. And here's above, you can see the formula right here, right? A times W naught to the power C times KVS. Now, if if you have a constant sweep, then it's 1.24 the KVS. If you have variable sweep, it's 1. Oh, sorry. It's 1.04 if variable sweep, and one is if it's a fixed sweep, right? So and A, you have the constant right here, and then the C is actually here, right? So you can see that depending on what type of aircraft you're designing, you can use this to estimate the empty weight. But again, this is very generic. That's why the first method is better, because that's specific for your design, right? So, and you can rely on Nikolai as well. If you look at chapter 5, he gives an equation to estimate the empty weight as a function of the gross weight of the aircraft. So you have the different aircraft types, and then you have the constant that goes into this equation, and then the exponents that goes into that equation as well, right? So it really depends. Again, you may or may not be able to find the type you're designing in this list. So that's why it's important. That's why you can actually rely on your historical data, right? If you actually also look at Appendix I on Nikolai, he basically collected a bunch of data and actually plotted empty weight as a function of takeoff weight. So this figure is for a fighter aircraft, but if you look in the Appendix I, he has for other aircraft types as well, which you can definitely use here for your empty weight estimation. All right. So that's our empty weight, the different types of empty weight estimation, or different methods to estimate empty weight. But keep in mind that you no matter what, you're gonna have to start with a takeoff weight estimation, right, to get an empty weight. So that's the hard part, but the thing is, you're gonna have to start somewhere, right? You're gonna start somewhere, and then through iterative process, you'll arrive at an empty weight, and the other weights as well, right? So the important thing is you start with a certain weight value, and this is why the historical buildup will come in handy too, right? You will know what type of order of magnitude of takeoff weight that you can use for the aircraft that you want to design, right? And depending on the mission, it'll give you the mission requirements. It'll give you a total weight of the aircraft, right? The gross weight of the aircraft, right? So this is basically the empty weight estimation. And I think this video may get pretty long, and when I cover the mission analysis, it may get pretty long as well. So I'm going to stop the video here, and in the next video, we'll talk about the fuel weight estimation and doing the mission analysis.